Hi guys, I'm Praveen. Today I'm going to talk about time delay calculation using one register, which is in microprocessor concepts. So let's see, as you can understand the concepts and using the problems. So let's see, come guys. Let's see what is the time delay calculation. I have taken one example for time delay calculations for one registers. So this is the program move registers to 10H. So it executes 70 states and it is decremented by C. So we have to take off of the 70 states. So it will decrement it by 4 and JNZ loop means if it is true 10 will be 10 times it will executed. If it is false 70 states will be executed. So in this program we had only one loop, that is the JNZ loop. So let's see in this program instructions. In this program, the C register loaded delay count hexa value is 10H. So we had converted into decimal. So 10H means is equal to 1 into 16 plus 0 into 16. So 1, 0, 1, 1 into 16, 0 into 1. So 16. We got 16 value for the 10H hexadecimal. The loop is repeated 15 times. It will take 0 to 15. So it will execute 16 times in this program. In this program. So then in this the instruction DCR executed 16 times and it takes 16 into 4. So it is decremented by a C register. So it takes 16 into 4, it is equal to 64 T states. And JNZ loop, if it is true, 10 will be executed. If it is false, 7 T states will be executed. So let's see the calculations part. So after that, the total number of T states taken for the execution for this program is given below. So MVI C 10H, 10H means is equal to 7 into 1. So it will always be 7 T states, 70 states, and DCRC decrement by C register is equal to it is off of these 8 bits, so it is equal to 4 into 16. So 16 means 0 to 15 times in the program will be executed because it is hexadecimal. So take 64 into 16, 64. So next is JNZ is equal to total JNZ loop is, if it is to 10 into 10 into 15 times plus if it is for 1 into 7. So it is calculated into 10 into 15, 10 into 15 plus 7. So we will get that the total is 157. So the total calculations of this T states is 7 plus 64, 71. 71 plus 157 is around 228 T states. Then next step is time delay calculation. Before we are going to time delay calculations, uh, there is a system frequency is 2 megahertz is equal to 1 into 2 into 10 to the power of 6 divided by 0.6. So we have to divide 1 divided by 2. We will get 0. Megahertz. So sorry, 0. milliseconds. So we will get 0. Milliseconds for that system frequency. So the total time delay introduced in the execution is programs. So let's see, let's calculate time delay for this program. The formula is total t states into system clock period. So the total yeah, we got t states is 228 into 0 point, and system clock period is 0 0.5. We will get 1.114 milliseconds. So we got 114 has a time delay answer. So let's see what we will get in the total loop is equal to 2 into loop t states is equal to n10. So this is the formula to calculate total loop where t is equal to system clock periods where 1 megahertz is equal to, so we got 2 into 10 to the power of 6, so it is 2 megahertz, so we got 10 to the power of 6, 2 into 10 to the power of 6, so we got 0 point milliseconds. So now we will calculate what is it, n to base 10 is equivalent to the decimal hexadecimal count, which is loaded into delay registers. So we the decimal count is we got as 16. So the total loop t states is 14. So we are now we can evaluate the total loops is TL is equal to 0 0.5 milliseconds into 14 into 16. So we got as 14 into 16, so 14 is belongs to t states, so we got 14 has the t states, so the milliseconds is divided in is expressed as 10 to the power of minus 6, 14 into 16. So now we will calculate the total loop is 0 0.5 into 14 into 16, so we got 112 as answer, 10 to the power of minus 6, so we expressed as 112 milliseconds. So now we got the total loop answer, so we have to adjust it that loop total loop as we got. So the total loop adjustment is TL. T indicates T states, L indicates loops, A indicates adjustments. So we have to make the adjustments for what we got in the loop statements. So we got clock period. So this is the formula for adjustment. TL. So we got TLA. So loop adjustment is equal to the total loops we got as 112. So which we indicates TL is equal to 112 minus 3 into 0 point is seconds. So we got, so after that we are calculating, we got 112. So we completed the loop adjustments. After that the execution of the instructions outside the loop. So let's see what is the outside the loop we will get. So outside the loop with 2 megahertz. So 2 megahertz. So let's calculate the outside the loop, t into outside loop t states. So this is the formula for to calculate the outside the loop. So where T is indicates a clock, system clock period is equal to 1 to the power of 2 megahertz. So it indicates as 1 to the 1 divided by 2 into 10 to the power of 6. So because it has a 2 megahertz, so 10 to the power of 6, 2 into 10 to the power of 6, so we will get 0.5 milliseconds. So in this problem, only one instruction present outside the loop, so that is move immediately to the C register 10H. So to execute the instruction, 7 T states are required. So the 7 T states are represent as outside the loop. So T0 into 0.5 milliseconds into 7. So according to the T states is clock period is given as 0.5. So into outside the loop T states is 7. So if calculate, we will get 0.5 milliseconds. So then we have to calculate the total delay. This is the last step for this problem. So we will calculate the total delay is equal to that. This is the formula for total delay to calculate the total overall the loops. So plus loop adjustments. So the total delay is equal to, so we will get outside the loop as 3.5 plus, and loop adjustments we got 110 point seconds. So the total delay we will if we calculate, we will get almost 114 milliseconds. So this is the problem. We got the answer has the total delay overall loops in this program. So I think it can understand it can, you can understand after solving the total delay of the time delay. So let's thank you.